Hey, welcome back. Have you ever looked at an equation with an x squared in it and thought, okay, now what? You're not alone. Quadratic equations show up everywhere, in physics, in engineering, even in video game design. And the good news? Once you understand the logic behind solving them, they stop being scary and start being actually kind of satisfying. So let's break this down together, step by step, and by the end of this video, you'll be solving quadratics like a pro. So what exactly is a quadratic equation? It's any equation that can be written in the form a times x squared plus b times x plus c equals 0, where a is not 0. The highest power of x is 2, and that's what makes it quadratic. Now, there are a few ways to solve these: factoring, completing the square, or the quadratic formula. Today we're going to use the quadratic formula because it works for every single quadratic equation, no exceptions. Think of it as your master key for quadratics. The formula says x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. It looks intimidating at first, but once you plug in numbers, it's just arithmetic, and we're going to do exactly that right now. Let's work through a real example. 2x squared plus 3x minus 5 equals 0. Before we do anything else, we need to identify our three coefficients. The number in front of x squared is our value of a, which is 2. The number in front of x is our value of b, which is 3. And the constant at the end, that's c, which is negative 5. That negative sign is part of c, so don't drop it. Write a, b, and c down clearly before moving forward, because one small mistake here will throw off every step that follows. Here's a smart move before diving into the full formula. Calculate the discriminant first. That's the expression inside the square root, b squared minus 4 times a times c. Why do we care? Because it's a preview. A positive discriminant means two different real solutions. 0 means exactly one solution. A negative discriminant means no real solutions at all. Let's compute ours. B squared is 3 squared, which equals 9. 4 times a times c is 4 times 2 times negative 5. That gives us negative 40. So we have 9 minus negative 40, which is the same as 9 plus 40. Our discriminant is 49, a perfect square, so we're guaranteed two clean, exact answers. Now we plug everything into the quadratic formula. X equals negative b, that's negative 3, plus or minus the square root of 49, all divided by 2 times a, which is 2 times 2, giving us 4 in the denominator. The square root of 49 is 7. So now we have x equals negative 3, plus or minus 7, all divided by 4. See that plus or minus sign? That's the key detail. It means there are two separate cases to compute, and that's exactly how one single formula always gives us two solutions. Let's find both answers. For the first solution, we use the plus. Negative 3 plus 7 is 4, and 4 divided by 4 equals 1. So our first solution is x equals 1. For the second solution, we use the minus. Negative 3 minus 7 is negative 10, and negative 10 divided by 4 simplifies to negative 5 halves. Now let's do a quick sanity check. Plugging x equals 1 back into the original equation gives us 2 times 1 squared, plus 3 times 1, minus 5. That's 2 plus 3 minus 5, which equals 0. It checks out perfectly. Let's recap what we just did. We identified the coefficients a, b, and c. We calculated the discriminant to preview our results. We plugged into the quadratic formula and split the plus or minus into two separate calculations. And we verified our answers by substituting back into the original equation. That's the full process, and it works on any quadratic you'll ever meet. Practice it a couple more times, and it becomes second nature. If this clicked for you, hit subscribe and ring that bell. We've got more algebra topics coming up that build directly on what you just learned. See you in the next one.